All right, again. So we want to know something that is the same, and we want to know something that is different about these two triangles. And I went on ahead and added two fourth grade words. So this specific type, actually it's a third grade word because you learned them in third grade. This triangle here is called an isosceles triangle. It's when you have two long sides and then the base is short or one short side. And then you have an equilateral triangle when all three outer parts, all three sides here are the same length. So that's isosceles and equilateral triangle. But other than that, what is something that is the same about the fraction of each model that is shaded? What's something that is the same about these two fractions? Yeah, there's one shaded here out of two equal parts. So that means the fraction is 1/2. And the same thing is over here. There's one out of two that are shaded. So again, the fraction is 1/2. So when I look at these two triangles, I notice they are similar because they each show 1/2 of the whole triangle shaded. That is something that I noticed that is similar between them. They both represent 1/2 of the whole. Now, what is something that I notice that is different? What's something that I notice that is different about the fraction of each model that is shaded? Atia should know this because she's been working on it. What's something that's different between these two? We know that this shows 1/2 of this triangle and that this one shows 1/2 of this triangle. But what's something that is different? Perfect. This one's a lot bigger than this one. I noticed the triangles are different because the whole for each one is a different size. So that means that 1/2 of this triangle right here, 1/2 of this one, is not going to be the same size as 1/2 of this one. And you can look at that and tell because this half is smaller than that half. If this was pizza or a cookie or something, I would much rather have the larger half than the smaller half. Even though they're both halves, the wholes are different sizes. So I notice that the triangles are different because the whole for each one is a different size. All right, last one, number 16, put it together. Use what you have learned to complete this task. Adam has 1/3 of a pizza, Hillary has 2/6 of a pizza, and John has 3/8 of a pizza. Adam, Hillary, John. Now I can go ahead and tell that they're eating square pizzas, but looking at these pizzas, they are all the same size. They all are the same size, straight across the top here. They're the same height, and they make just completely the same size. So we're talking about the same size of pizza. We are going to, and I'm going to do this one. Adam has 1/3. I'm going to do this one. I want you guys to do Hillary and John. Show the number of equal parts in each pizza. Then shade each pizza to show the fraction each person has. So if Adam has 1/3, I know that looking at a fraction that the denominator, which is this number right here, tells me how many pieces to cut the shape into. So if I have to cut it into thirds, and I always do the best that I can. So that looks pretty good, but that bottom one's kind of too big. So I'm gonna bring that down, bring that down. Looks like I did pretty good thirds. If Adam has 1/3 of a pizza, what is that going